Hello, this is Kara Tierney from Monroe Community College, and in this video we're going to continue our discussion on quantum numbers. And previously I gave an introduction to quantum numbers, and we talked about the first two quantum numbers, n, which defines shell or level, and L, which defines our subshell or our sublevel. In this video, we're going to further define our M subscript L, and that's going to specify exactly which orbital within the subshell the electron is located. And the last one, electron spin, which is M subscript S, that defines which particular electron within the orbital we're talking about. So when we're talking about M subscript L, this is called the magnetic quantum number, and it's defining a particular orbital within each subshell that the electron is located in. So what these quantum numbers do is they're just defining the location of an electron. So the more M numbers that are defined for an electron, the more specific we're getting in that electron's location. So the value of M sub L, which is what I'll call it, defines a particular orbital. And so we're going to go through each subshell type so I can explain what the different values are and how many values there are for each. For our first type of subshell S, and you can start filling this out in the table, our subshell S has one L value. If you recall, the L value was 0, and there was just one orbital. So that means there's only one M sub L value that is allowed, and that would be M sub L equals 0. There's only one value of M sub L because there's only one orbital. So each value of M sub L determines the orbital. Our next type of subshell, the P subshell, has an L value of 1, and there are 3 orbitals. Each orbital has a different value of M sub L. Now, we don't need to know specifically what the value for each particular one is, but there are values of -1, 0, and 1. So the values of M sub L that are allowed go from -L to positive L, and they're all whole numbers. So L for P is equal to 1, so we can have values of -1 to +1. So -1, 0, and +1. These are 3 values for 3 orbitals. So each orbital gets its own value. When we look at D, there are 5 orbitals, okay? So M sub L is going to have 5 different values that are possible. These go from -L to +L. So they go from -2 to +2. So we have -2, -1, 0, +1, and +2. I'm sorry, my video capture program loves to underline things when I don't want them underlined. But anyways, this is a value of -2 to +2. So you see that there are 5 values, and that is because there are 5 orbitals. One M sub L value for each orbital. And our last type of subshell, F, has an L value of 3. There are 7 orbitals, so there will be 7 M sub L values, and these values go from -3 to +3. So we can have M sub L values of -3, -2, -1, 0, +1, +2, and +3, and that is 7 values for 7 orbitals. So when we look at our table here, if you were not able to complete it, here we go. This is the completed table for you. We see that each subshell type has its own L value, and then there are corresponding M sub L values that are allowed for each. And the number of values that are allowed correspond to the number of orbitals within that subshell. Once you have the first 3 quantum numbers defined, we know exactly which orbital the electron is located in. Our last quantum number, the m subscript s, or the electron spin quantum number, is defining which of the two electrons we're talking about. So each orbital has a capacity for 2 electrons, and each electron then needs to be defined. So we define which electron we're talking about in this quantum number, and it either has a positive half value or a negative half value. These values are somewhat reflecting the direction of the electron's spin. It has to do with its momentum. We're really not going to get into the exact definition of what the positive half and negative half mean. Just know that if you have 2 electrons with their first 3 quantum numbers equal, they have to have different values of m sub s, because when you have 2 electrons in the same orbital, one has to be spinning in the opposite direction as the other one. So no 2 electrons within an atom can have all 4 quantum numbers equal to each other. So let's take a look at our next problem example 3, to kind of clarify some of these quantum number values. So in problem example 3, the question says, which of the following is not an acceptable set of quantum numbers? Circle 1. Well, why don't you give this one a try right now? See how you can do with it. If you get stuck on it, feel free to start the video again. So of course you're going to pause this right now, try the question, and then press play when you either finish or if you get stuck. So here we have to consider what values are allowed, and when we do this, you need to relate each quantum number to the quantum number that came before it. So let's just take one at a time. And so we're going to look at A. A has n equals 3. So if you recall, for our L value, L values can go from 0 to n minus 1. L equals 2, that is within 0 to n minus 1, so that's acceptable. So now let's look at our m sub L. M sub L is allowed to go negative L to positive L. So our values would be negative 2 to positive 2, so that's okay. And just make sure your m sub s is either positive 1/2 or negative 1/2, and you're fine. So A is acceptable. Let's look at B. N equals 4, so L needs to be from 0 to 3. It is. M sub L needs to be, if you have an L equals 0, M sub L has to be 0. So B is okay. Let's take a look at C. N equals 3, so our L value needs to go from 0 to 2, and it has a value of 1, so that's okay. So our m sub L can go from negative 1 to positive 1, so that's okay as well. So D must be our answer. Let's find out why. So for D, n equals 4 and L equals 4. Well, if n equals 4, we can only go from 0 to n minus 1, and that's because in the n equals 4 shell, we can only have 4 subshells. And they start with values of 0. So we can have 0, 1, 2, or 3. That would be the 4 subshells. So L equals 4 is not possible. And so D is the answer here. Just as a reminder, n has to be a whole number. L can go from 0 to n minus 1. M needs to be from negative L to positive L. And M sub S either needs to be positive 1/2 or negative 1/2. So in our next video, we're going to do an overall summary of quantum numbers and the quantum mechanical model,